Today's lab is called Slinky Science, and we will be using a slinky to investigate the differences between potential and kinetic energy. So first, let's make sure we're on the right page. This is the page we're working on. You can see it's titled Slinky Science at the top, and we'll come back to that in just a second. So a quick review of a couple of our vocabulary words that we're going to be using a lot today. Potential energy and kinetic energy. Go ahead. You're all right. Thank y'all for waiting. Thanks, girls. All right. First, let's go over a couple vocabulary words that we're going to be using pretty extensively today. Potential energy and kinetic energy. So we need to make sure you understand the difference between them. So if I take a marker and I set it on top of this book, is it moving or is it not moving? I mean, pretty obviously it's not moving. So my question to you is this marker showing potential energy or kinetic energy? Well, it is not moving now, but it has the potential to move later. So when something is not moving, is at rest, that is showing potential energy. Because no, it's not moving right now, but it could later, meaning it has the potential to move later. Now, when something is moving, that is called kinetic energy. Kinetic energy is the energy that something shows when it is in motion. Kinetic literally means moving. So, kinetic energy is when something is actively moving at that moment. Potential energy is when something is not moving, right? I'll turn it this way so you can see it. Potential energy is when something is not moving. It is not moving right now, but it has the potential to move later. Potential energy and kinetic energy, moving at that moment. So those are the main two things you need to make sure you're aware of to get through today's lesson. So let's pick up our sheet, let's look over our questions so we are aware of what type of information we're looking for. So 1A says, what type of energy does the slinky have at the top of the stairs? 1B, what type of energy does this convert or change to as it goes down the stairs? Question 3, why can't the slinky go up the stairs? I'm sorry, that was question 2. Question 3, will there be a difference in the speed of a plastic slinky and a metal slinky? Question 4 tells you to complete this hypothesis related to the speed of them, and it gives us a hypothesis that we'll need to fill in. And question 5, was the hypothesis is accepted or rejected, and then explain why. So let's start up here at number 1. So 1A and 1B. 1A says, what type of energy does the slinky have at the top of the stairs? Well, if we put our slinky at the top of the stairs and we set it there, is this potential energy or kinetic energy? Well, if you're ever trying to figure out if something has potential energy or kinetic energy, just ask yourself, is it moving now or is it going to move later? So, easy answer. Is this moving now? No. Could it move later? Yes. So that is potential energy. Once the slinky starts to move, then that potential energy has converted into kinetic energy. All right, so when something is, like we said at the beginning of the video, when something is not moving, it is potential energy. Whenever something is moving, it's kinetic energy. So, looking at number 1A and 1B, what type of energy does the slinky have at the top of the stairs? So, what type of energy is that? And 1B says, what type of energy does it have as it is actively moving down the stairs? Now, the slinky travels down the stairs because of Earth's gravity, right? Earth's gravity pulls everything towards the center of the Earth. So the center of the Earth is below us, So whenever we start a slinky, that slinky continues going because Earth's gravitational pull continuously pulls the slinky down the stairs. So the question is, why can't the slinky go up the stairs? If I start my slinky at the bottom and I place it on the top and let it go, will it go up or will it go down? It will go down every single time. No matter how many times I try to start this slinky to go up the stairs, it's always going to do what? Go down. So your question for number 2 is, your question for number 2 is, why can't the slinky go up the stairs? The slinky cannot go up the stairs for the exact same reason that the slinky does go down the stairs. Gravity is what pulls the slinky downward. So we're watching gravity take its effect on this slinky. And because of gravity always pulling down, anytime we try to start the slinky going up the stairs, gravity will always pull it down. So that's your answer for question 2. All right, question 3. Do you think there will be a difference in the speed of a plastic slinky and the speed of a metal slinky? You can't feel them in your hands right now, so I'll make some observations for you to kind of help you understand the difference between these slinkies. Well, I can tell you right now, if I pull a little closer, I can tell you right now this metal slinky is a bit heavier. I would probably say at least 3 or 4 times heavier than the plastic slinky. All right, so the plastic slinky is lighter, the metal slinky is heavier. If we look at the coils here, let's see if I can get these to stop moving. All right, if we look at these coils here, and when I say coils, right, slinkies are just one giant coil. A coil is something that is wrapped around itself a whole bunch of times. Like if you can describe a snake as being coiled up, meaning the snake is wrapping up on itself. So slinkies are just giant coils. Right? It's just one piece, one strip of material wrapped and wrapped and wrapped over on itself. And we can also say that each one of these layers is one coil. And if we look at the difference in these, we can see that the metal slinky has a lot more coils. See if I can get in front of my shirt. The metal slinky, right here, has a lot more coils than the plastic slinky. And what that does is, it means the metal slinky has a much tighter force pulling it together than the plastic slinky. So all these extra coils means that this metal slinky is wrapped much tighter than the plastic slinky. So a couple main differences that we said is that the plastic slinky is lighter and the coils are looser. The metal slinky is heavier and the coils are tighter. And one more thing that we can look at, let's see if I can start it right here, is if we start both of these slinkies together at the top, I'm going to lift them up, then we can see that the metal slinky is much longer. So you can see the bottom of the plastic slinky bouncing up and down. The metal slinky is almost touching the floor. So the metal slinky is also a lot longer. Now, with that information in mind, look at number 3. Will there be a difference in the speed of a plastic slinky and a metal slinky? So we sent our plastic slinky down. Do you think there will be a difference in how fast this metal slinky goes down? So go ahead and answer yes or no in number 3. Now in number 4, we have to complete a sentence. So looking at 4 right here, it says complete this hypothesis. And in science, if you don't already know, a hypothesis is just an educated guess. Anytime a scientist is doing an experiment, the first thing a scientist ever does before he does an experiment is first he thinks, what will be the probable result? What do I think will be the result of this experiment before I test it? And that educated guess that the scientist makes about the result of the experiment is called a hypothesis. So what you're doing is you're making a hypothesis right now. We're going to experiment whether a plastic slinky or a metal slinky will travel faster down the stairs. You have to complete this hypothesis on which one you think will happen, which one you think will be faster before we test. So, number 4, complete this hypothesis related to the speed of them, meaning the slinkies. And it gives you the first half of the hypothesis. You have to fill in the second half. So, if a metal slinky and a plastic slinky travel downstairs, then, and you tell me which one will go faster or slower. If a metal slinky and a plastic slinky travel down the stairs, then the metal slinky will go faster, or the metal slinky will go slower. Or you might write the plastic slinky will go faster, or you might write the plastic slinky will go slower. Whatever one you think will happen, be sure to fill it into the blank on number 4. So maybe you think the plastic slinky will go faster. That's what you fill in right here. Maybe you think the metal slinky will go faster. That's what you fill in right here. So take a second, write that down. Let's try our slinkies out and see what our test is. So first we're going to start with the plastic slinky. What I'm going to do is I have a stopwatch. I will start the stopwatch whenever the slinky begins descending, and I will stop the timer once it reaches the bottom. So 3, 2, 1. All right, this plastic slinky took 1.87 seconds to descend the stairs. Now, any good experiment, we should know by now, has multiple trials. So we'll look at it again to make sure our results are accurate. So the first trial took 1.87 seconds. Let's start it again. 3, 2, 1. Second slinky took the second trial for the plastic slinky took 1.78 seconds. So both times it took about 1.8 seconds. So we can say the plastic slinky takes 1.8 seconds to get down. All right, metal slinky trial 1. 3, 2, 1. All right, that time it took 2.87 seconds. So the metal slinky took about 1 second longer. Let's do a second trial to make sure our results are accurate. So metal slinky trial 2, 3, 2, 1. Metal slinky trial 2, 3, 2, 1. And that time the metal slinky took 2.38 seconds. So the plastic slinky took 1.8 seconds to go downstairs. The metal slinky took over 2 seconds to go down the stairs. So which of these was quicker? Plastic slinky, 1.8 seconds, or metal slinky, over 2 seconds? And our trials show that the plastic slinky is the one that went down the stairs faster. So let's go to our last question on our Slinky Science page. We're down here at number 5. Hypothesis, accepted or rejected, circle 1. If you had said that the plastic slinky would be faster in your hypothesis, then you need to circle accepted. If you said that the metal slinky would be faster in your hypothesis, then you need to circle rejected because your hypothesis was incorrect. And then you need to explain why the plastic slinky traveled down the stairs so much further or so much faster, because you would think the metal slinky, it has a tighter coil, it's heavier. You would think that gravity would pull it down faster and it would travel faster because it has a tighter coil. The plastic Slinky went faster because it wasn't as long, right? Even though the gravity should pull the metal Slinky faster because it has a greater weight, it should be pulled down faster. And even though the metal Slinky has a tighter coil, which means it should spring faster, because the metal Slinky is so much longer than the plastic one, before the metal Slinky can descend each step, it has to wait for all the other half of the Slinky to catch up to it before it can start the next one. So even though the metal one we would think should have gone faster, the plastic one actually went faster because it was shorter. Okay, so that's all for today's lesson. Make sure you get this page glued in your science journal and make sure you record it on your table of contents. Thank you.